Hey guys, super happy to be here once again. And today I'm very, very excited because it's not just that I have a very special guest today, but I have a guest that he's also a neighbor. And I'm very,
Sure,
very
sure.
excited. And I think that we're going to discuss over some very, very interesting things, small to medium firms and things that really like keeps me and the guests very enthusiastic about what we do. Um, so without diving into much details right now and letting you the pleasure to listen to the podcast itself, I'm very very happy and grateful for the opportunity to feature you, Harris, here on the podcast. So first of all, thank you for being here. It's a pleasure, and yeah, how are you? And in that time, please tell the audience a little bit about yourself.
Sure, sure. Yeah. Thanks a lot for having me. Quite excited also for this kind of dialogue. And who am I? Okay, I was born in Greece, studied in Greece.
Kalispera.
Exactly, exactly. Started in Greece, applied computer science, did my master's also in applied mathematics, and then left to work at the European Central Bank for 2 years, and then moved over to the States, did another master's there in financial engineering. And since then, basically, I started working in the quantitative equity space as a quantitative researcher and as a PM lately. Yeah, that's a little bit about me in terms of kind of background, work experience. I worked in Hartford Funds, BlackRock, some of kind of the more well-known names. And in terms of free time, whenever I have it, Brazilian Jiu-Jitsu, music, that's what kind of keeps me excited.
Resilience, music,
Brazilian Jiu-Jitsu.
jiu-jitsu.
Yes, exactly.
Oh, okay. I think that we will like what is the Brazilian jiu-jitsu?
Is wrestling with chokes and dislocations, basically arm bars, knee locks, and chokes.
Well, I don't really want to fight you, but okay.
Yeah, I'm still starting out, so don't worry.
Fight you right now. But yeah, that's very interesting. That's very intimidating. Look, I've never had about Brazilian jiu-jitsu, but here in Israel, like you have plenty of different you know we
Krav Maga, right?
I was I used to do capoeira when I was young, if you know capoeira.
Yeah, yeah, I do. Nice.
And I like the Brazilian rhythm and the Brazilian attitude for this kind of sport, and I think it's very fascinating,
True.
to do that. Like I remember the berimbau, if you know like the tool, the instrument that you can
Yeah.
play. My parents bought it for my birthday when I was 9 or 10. I don't remember, but never mind. Yeah. So BlackRock, applied computer science. Very well known. The type of the guy that aligns with the industry standards. Um, let's start from the end.
Go ahead.
Um, let's start with your experience in the industry, and I would like to ask you. Okay, you have done like all the applied computer science,
hmm
all the degrees in your academic period, in your academic journey, and over the period in the industry, I would like to ask you, how have you utilized your academic background in implementing in practice uh, mathematical equations, for instance, or various different types in order to like in the models, in the trading models themselves.
Yeah, yeah. I mean, they go hand in hand. So, and that's the way it's kind of like applied, right? I always like the applied side of things, and this kind of industry is one that you can really apply it right away. And what I then mean by that is, okay, you need to learn programming because at the end of the day, you're kind of programming everything in order to be implemented. And now it comes to the question is, okay, what are you kind of programming, right? At the very least, there are like two different ways. One is the kind of the investment banking and option trading route, at least when I was in the university. And then the other one was into asset management. I kind of chose to go to the asset management because I kind of liked it more. And then what you're trying to do is basically, okay, I would like to have a portfolio of stocks, let's say in the simplest case. And how I can combine it is you can go and kind of read and analyze all the kind of the news, broker research, earning calls you can do. on your own, or you can write a program to basically analyze those data and then take decisions for you. So that's basically what the kind of financial engineering does within the asset management, right? And to answer your question, basically, like a quant utilizes like statistics, mathematics, and programming in any kind of, depending on where he's at in the research phase of the project to utilize it. Early on, you use more lot stats and math to kind of filter out even the equations, what kind of view you would like to have. Let's say you would like to predict the returns of a stock. You need to come up with a model and you need to design that model, right? So that's more in the beginning, and then you kind of go into kind of coding it, building a prototype, and then if you see a light at the end of the tunnel, you kind of go through the full project.
Okay. And how?
I'll pause here. Yeah, let me know if it makes sense.
Yeah, it makes total sense, you know. Now, how do you evaluate? You said that before deployment you create a certain prototype, which is very interesting. I have never heard of anyone who does prototypes before you. And my question is, what do you mean by saying a prototype, and how do you evaluate that prototype?
Yeah, that comes to how do you evaluate strategies, right? So you can kind of spend like 3 months, 4 months building a strategy and then finding out it doesn't work. So you need to create a research pipeline where you can have like a fast or quick feedback and evaluation. And that's what I mean by prototype. Like you need to be able in kind of short amount of time, let's say like 2 to 4
Forward.
weeks.
You
Yeah,
do a certain forward. Develop,
exactly.
test, develop, test.
Yes, you need to be like iterative and you need to be like experiment fast. That's kind of like where I'm coming from. So the prototype needs to kind of test the idea, let's say like 60, 70%. And you need to be able to say, okay, now I need to kind of go and build it. So I need to spend more time, or like put it on hold or even reject it, right? That's what I mean by prototype. And then evaluation is kind of depending what you're building. It could be like another kind of ML model. So then you need to look at the ML stack, like, the precisions, the recalls, or, any of the kind of loss functions that you want to have. Or if it's like a more of a signal to trade, then you need to look at, returns, the ICs, sharp ratios, etc. So it kind of depends on what you're working on. But basically, yeah, I'll pause here.
No, why? Look, okay. So you have mentioned that you need a quicker research file, okay, for testing and trying to see if your ideas can be worthwhile at some point. And my question is directed to you is how do you build that funnel? Because obviously you have an idea of what you're going to do, but how do you actually engineer it properly so you get the quick responses to see if you need to evaluate your strategy, evaluate like the tech stack of the machine learning model, which is the thing that we're going to be speaking about in the next few minutes. And yeah.
It kind of depends. It is an engineering task, so you need to like, I mean, all the established firms they do have like a research pipeline already established. But if you're starting from scratch, what that basically entails is you need to um, go to like signal generation, signal evaluation, and then some sort of like portfolio construction, and then again another kind of portfolio evaluation, and then deployment. These are kind of the three different pillars that you have to go. And then the research pipeline and the execution pipeline basically are horizontal and build on top of that, right? So the question is, okay, how can I do quick signal evaluation, right? How can I build it? For example, to give you an example, back in the days, you could take a signal and you do like very basic deciles or quintiles. So let's take momentum, you decile it, you see what its decile return is, and what's the spread between like Q10, Q1 or Q5, Q1. That's an example of like quick evaluation. So you need, and there are other techniques like more cluster based, et cetera, et cetera. But they're like, these are kind of techniques that once you have the signal, you don't need to spend like a lot of time optimizing it because you need to also not to avoid the kind of overfitting as well. So it's also a fine balance. How much time do I need to spend versus how much time I need to fit this? So it's also, like a lot of other criteria that go into that as well.
Okay, but do you evaluate your ideas with proper You obviously evaluate your ideas with proper testing and research. And my question is that obviously you build an intuition to evaluate your ideas. And I would like to ask you, after a long time doing that, what do you think are the things that you avoid like instantly when you have a new idea or a or a new thesis that you would like to test? What are the main core structures that you start from? Like what's your starting from? And what are the like type of things that you never touch or instantly avoid?
Yeah, that goes from the end. So what you want to do is you would like to have a signal that will be part of your portfolio in production. So if you know that this signal might be very correlated with the signals you already have, then you need to check that very, very first at the beginning. Because also you would like to avoid having like a really good signal, but also being highly correlated with the rest of the book. So that's something you need to check like very early on, so you don't spend a lot of time there. Another thing is, how am I gonna trade this in practice? So let's say you have, let's say, daily signals, and all of a sudden you have something that trades every minute. So you also need to be like you need to know, like, okay, this signal, if I put it, it will basically trade like every minute, and the rest of the signals trade only one a day. So now basically you're skewing everything towards that signal, and everything else becomes very just like 1 point over those, like 1440 minutes that the day has, essentially, right? So these are kind of the implementation considerations that you need to take. So then you say, okay, I have it every minute. Maybe I need to smooth it out and maybe make it every hour, or, do something else. But these are some of the considerations that you need to take when you're kind of combining different signals. It's like, okay, how this will impact the portfolio, how I'm going to trade the signal in production.
Mhm. I understand. And okay, that's interesting. But I'm trying to brainstorm with you about like,
Mm-hmm.
you know, you have mentioned that you're doing that type of research, and right after, you have spoke about your intuition, which is understandable. But now let's go from the beginning and let's try to articulate how it's like
Mm-hmm.
the initiation of a strategy. Like, what is the thing that initiate the idea, or like
Yeah.
how do you find a reliable trading ideas? Now, obviously, it's a thing that you cannot disclose. That you cannot share like
Yeah.
from full in depth, but just to give us a sense of understanding of how do you think, that would be great.
Yeah, yeah. I mean, there are two things. One is there are two the approach is different if you're starting out versus if you're already running a book in production, right? And I'll tell you why. Like, in order to create a book from scratch, basically you have zero signals and you start building up. So there, the probability of finding a signal that works is obviously higher. It's like one, right? Like when the first signal you find it works, you put in production, and then you start increasing the signal pool. So then you will reach a point of time where you're researching ideas, and the probability of that actually meeting in production is very, very, very low, because, well, they will be highly correlated, will not add value, they will not be orthogonal. So that's why you need to distinguish between the two. So to answer to your question, let's say you have a strategy that's already working. You have, I don't know, 20 to 100 to 1,000 signals, depending on what kind of frequency you're trading. The idea is, I would like to make my strategy better. So now you start to look where your strategy is losing money. Is it because of, like, where the drawdown coming? Is it because of a particular point in time? Is it because you have some particular exposures that you're not capturing? So you need to identify where you need to improve, and you start with that. So let's say that you have a high vol and you need to drop the volatility. You could kind of try and find out a signal that's like a low vol signal, or is like anti-correlated, or maybe you need to kind of average the signals more, or you need to do something additionally to bring down the volatility, or maybe you need to change the trading and not trade so often. So you need to trade, like, let's say you're trading like every hour. Maybe if you do it like every 2 hours, that kind of also kind of reduces the volatility as well, right? So it really depends what you're working on. Or let's say you really want to go after like high sharp, you want to increase your returns a little more. So then it makes sense to become more aggressive and trade more often. Um, so it really depends on what you like to do, and then you kind of evaluate. Like the stack of evaluation is kind of the same. At the end of the day, you will have the same stats, and then you kind of iteratively compare the baseline, what you have versus the addition. And usually you change one thing at a time. Let's say you like to test the volatility assumption. You only test that and you see whether there is like difference between the portfolio you have and the portfolio that you'd like to go. And then incrementally, change stuff as you go.
Mhm. That makes sense. But before we'll continue talking about
Mm-hmm.
that issue, I would like to jump on the Book of the Signals, which is
Mm-hmm.
supposed to be first and foremost is supposed to be very well defined, just in order to understand what are you talking about and what are you actually referring. And the other thing is how do you, as a quantitative research, how do you analyze it?
Mm-hmm.
Like how do you extract like the majority of the understanding out of the book in order to understand, I don't know, the variance or the invariance or the orthogonal signals exactly as you have mentioned, which is another interesting topic that I would like to explore with you.
Yeah, I mean, let's discuss like momentum, for example. That's like well, very well documented, and I'm not spitting any secrets. So you can do like residual momentum, obviously, right? Like if you try like the pure momentum, let's say the return over whatever period you want. Basically, the long-term momentum is defined like the T minus 12, T minus 1. That's like a momentum of the long-term period. And then you can similarly do it over like shorter time frequencies, let's say over 1 hour, over like 6 hours. Usually, if you try to apply that as is, it will kind of fail. And it fails because it has like a lot of other components that you're carrying with it. So if you take the total return, then that has also other components in there. So you need to be able to strip out whatever systematic components you have and then focus on the idiosyncratic component and capture that alpha basically, right? So if you go to like the basic regression, you know, you have the return and then you try to decompose it. And that also connects with the covariance that you want to get afterwards, right? So there you have what the alpha component is, you have the beta, and then you also have the residual idiosyncratic, right? The idea is to control as much of the beta you can, remove it, and then idiosyncratic should be zero on average. And then you're left with the alpha that you're trying to control. So residual momentum is basically that, like a very tangible approach of how you can take that, regress it against some known factors that you have as the risk factors, and then take the alpha component of that and run momentum on that alpha component. Again, that's like a very kind of well tested idea, but that gives you a sense of how you need to think about modeling this kind of stuff. And then there are other stuff, like you need to be like sector neutral, for example. You take that signal and then you need to take sector effects out of it. So you neutralize it against sectors. Um,
How neutralizing sectors or sector neutral component actually influences the book itself.
it influences a lot, especially sector, especially in US and European books. Sectors affect a lot because they drive a lot of the variance, a lot of the risk. So if you're running like a US book, sectors will play a very, very high role. If you're running like a global book, then you have countries, sectors, and currencies. So you could be making money on a US stock, but if you're investing in euros because the euro USD exchange is going up, then essentially you're probably flat or losing money. A typical example of that, like S&P, like if you're like a European investor, invest in S&P 500, like, and you look at this year performance, you'll see that's pretty much flattish. And then you say, oh, why is that? Well, you have currency effect, right? So it's kind of similar that you need to take all of these kind of risk components out of the equation because they affect. You want to have the alpha component only. So sectors, countries, currencies, plus the risk dimensions. And how you do that, the easiest is to do a regression on top of that. You take the total return, regress against all of those factors, and then you have the alpha component, the residual component that you work with. And then there are the clustering techniques that you can work on top of that. You can use like LightGBM, for example, to do the same thing. And then you have features that playing.
What do you mean? What do you mean? Like JBM in order to do what? In order to map
Let's say
out.
you Yeah, let's say you want to predict, like, let's say you have the total return and you would like to find out, okay, which of the features that you have are contributing the most. So then you can look at the feature importance and figure out, okay, those
The feature
features.
importance, but how do you utilize machine learning here? It's not supposed to be like statistical variance test like PCA, VIF, something that like that explain you the variance and then you make your assumption. Like I don't really understand that like the intersection with machine
mm,
learning here.
Yeah, it's another approach. You have to think a way of the PCA type approach. I mean, PCA is also a machine learning approach. It's just like linear. And then like the machine learning goes into the non-linear case. So regression is linear, right? So it's a linear model. Once you go to machine learning models, basically you can do the same thing in a non-linear fashion. I mean, you can add like non-linear components to the linear regression as well. But the machine learning comes to help and add that non-linearity into your kind of understanding of how things work a little bit more.
Okay.
Um, that's how we would utilize it basically.
Okay, and then you plug into okay, now it's understandable. You plug in gradient boosting methodologies, which is tree upon tree upon tree, and then what do you do is like you trying to understand the nonlinearity in between like what was like the most influential feature that like caused I don't know
Yep.
60% of the variance,
Yeah. Exactly.
hypothetically.
Yeah.
That's
Exactly.
interesting. That's interesting. Okay, that's nice.
Yep.
That's an approach that I didn't really met with. Okay. Um, okay. That sounds fascinating. Um, okay, let's go back onto the model development process. Okay,
Mm-hmm.
now after you understand how do you initialize those trading strategies, and then you have an idea, sector neutral, non-sector neutral. You understand like the amount of capital you're going to trade with. Then you have an idea what do you want to trade and like time frame and everything that is supposed to be included.
Mm-hmm.
So you have an idea. Now I would like to dive deep into the rest of the process until deployment, including deployment if possible,
Mm-hmm.
to understand how do you work with the process that you have created, how do you capture the things and how do you utilize each and every single thing in the research process in order to leverage it towards you probably.
Yeah, I mean, what you want to talk is about execution essentially, right? So once you have a model, how do you execute it in practice?
Execution, like what's the important factors that you're looking after. Machine learning, tech stack might be very interesting topic to speak about. So
Mm-hmm.
look, I have uploaded three. Now you will decide what do you like to talk about.
I think we can touch a little bit on all three. I mean, machine learning is basically a horizontal line, right? You don't use it only for only for the research. You can also use it the execution as well. Um, but it's something that also happens continuously, right? So you continuously fit the model, refit the model, and get the new predictions, and you have it up and running. And everything is a loop, right? You have new ideas that will get pulled in what is called like the alpha pool, and then that gets combined into one unified model at the end of the day. So you put ideas there, and then you have already what we discussed about how to evaluate and pick strategies. That gets picked, becomes one model that spits out predictions for each of the stocks that you would like to trade. And now it's okay. Once I have that, like how, and we'll go to the tech stack as well. How do I execute in practice? That's the more straightforward part. You basically connect to a broker or multiple brokers. You have the list of instructions. Let's say I would like to buy Apple, 100 shares with a TWAP over the next 3 hours. You connect through a stream to the broker, and then you send the orders, and then basically the broker will kind of execute your trades. And then some of the factors that you look at is kind of depending on how much, what are you trading, and how much capital you're trading. There, you need to be careful about the market impact. So if you have like a very large capital, you need to be very conscious of how to spread it. That's one. If not,
Speaking about
usually,
don't speak about sizing, correct?
Yeah, sizing, but like if you have like a 10 million lot versus, like a 50 million, 100 million lot, there are different considerations as to how to trade them, right? So sizing, lotting them, and how to split them in the market, it's very kind of very important. And then once you have the fields, you take all of that data from the execution side, and then you try to also analyze them, right? So you need to analyze what is the field, how much you're spending in trading costs. If you're shorting, what is the short locate, what is the borrowing fee. So there's like a lot of analysis that goes into execution part. And then, of course, once you have the real P&L, you need to compare that with the backtest P&L. And that's basically, I think, one of the most important aspects because at the end of the day, whatever you do at the research part, the realized performance is the true validation against the backtest performance. So if these two go together, that's the spot that you like to be at. And I'm saying they have to be profitable, but if your realized P&L drops, also your backtest P&L should show that drop the same. If the
I,
realized goes up, the backtest should also go up.
I had another guest
Mm-hmm.
a few days ago. He's a very famous individual, and
Mm-hmm.
he told me that he changes like the backtest environment rules, like according to the to his training strategy. And obviously explained the rationale behind it.
Mm-hmm.
Now, that was a very interesting conversation about like backtest environment and like the things and the considerations you would have to absorb when you want to actually backtest an idea or strategy,
Mm-hmm.
basically. Now, I would like to ask you, what is your point of view over backtest? Like, how do you backtest your strategies? How deterministic the process is supposed to be? If you use vectorized backtesting, if you use third-party code, if you use third-party or open source, how much reliance would you give on it? Or another question, nowadays there's still need to rely on third party, or you can take that third party, make some further adjustments and modifications and plug it in as a code that you have just created, just took
Yeah.
the idea behind like the idea behind the code or the architecture behind the code.
Yeah, so in terms of backtest, that is kind of a heated debate, right? Like a lot of people have different opinions in them. Some of them will tell you,
Very
well,
much needed.
yes, exactly.
A
Uh,
heat
uh,
map. A
yes,
heat map.
exactly. It is a heat map, right? I mean, there is like I think uh, the truth I think lies somewhere in kind of the average of all of those kind of opinions. Yes, you cannot rely only on one kind of sample path and say, oh, it's kind of profitable, so we'll run it based on that. So you need to kind of include some variability and some sort of stochasticness into that. That's where kind of like Monte Carlo approaches come into play. That's where like people talking about synthetic data. So you need to get robustness. That's at the end of the day, you need to be like robust signals. And robustness comes by being battle tested in different periods, different regimes, and only testing continuously on only one sample path will get you to overfit. So it is an art of how to create like a very good backtester. I don't have the perfect answer, but some of the things that I try is to do some kind of like Monte Carlo to add the variability. I try to
Like,
not.
wait, you do Monte Carlo for the backtest results, then you take a sample of like 50 different occasions, and then you sample over Monte Carlo, and then you like to see if it is enough
Yep.
resilient. And by the way, what is like the type of the angle of the MC that you're trying to target?
The angle of what? The MSC.
The Monte Carlo.
Basically, the Monte Carlo gives you a lot of different sample paths, right? So you would
Uh-huh.
like to see if I change the input, what is the output response? And instead of having like one value, let's say you run one backtest on the realized path, you get one Sharpe ratio, one annualized, and one fall. But then if you have multiple runs, you get a lot of different values. So then you go to Monte Carlo, you take the average, you take the volatility of that estimator, and you would like to see how robust is your estimator, essentially, your strategy, to all of these different sample paths.
Hmm.
And that's why Monte Carlo, it's useful because it allows you to do this kind of stuff. Now you can do like bootstrapping again. It's another technique similar to Monte Carlo where you take the your return sequence and you kind of bootstrap it. So you take like different, you kind of sample with some sort of like autocorrelation in there. Um, and then at the end of the day, you also need to have like holdout sets, similar to you do the machine learning pipelines. You definitely need to keep a set of data throughout your time that you haven't kind of tested, you haven't seen it, and you only need to really literally test it only once. So let's say that you do all of this backtesting, robustness, etc. You still, in the end, you need to have a set of data that you haven't touched. You run it there, and that gives you basically another proof of point that, yeah, it kind of makes sense. Uh, if it kind of, yeah, that's kind of the true out of sample, as I call it. Like if that succeeds, then you can kind of go ahead and put it in the staging environment where you perpetrate it. If it goes well there, then you switch it to the live prod.
Okay. How important is the stochastic evaluation of each and every single hypothesis that you're actually extracting? Like,
Mm-hmm.
like when do I say an hypothesis, I refer to the different set of parameters for the Monte Carlo, for example.
Mm-hmm.
So that's what I refer to. And how important it is to measure the stochasticness of of that process. Like if like you can do it 100% stochastic and like to get very, very messed up with all the different results, which I think
Mm-hmm.
like most majority of them are complete noise, but you can do it much more narrowly, and from that narrow process, you can extract multiple ideas for the continuation. Now, that's my point of view, and I would like to ask you, what is your uh, what is your take on it?
You definitely need to control how much noise you induce into the system, right? Because there is already a lot of noise through the computation, through the data. So I kind of agree. If you add a lot more noise intentionally, that will also push things not in the direction you really want to go to. So definitely you need to measure how much noise you're adding. But also that's also where kind of Monte Carlo comes again into play, because if you had a lot of noise, you will see that in the results they will be kind of all over the place and you won't have any value. So there is something that's called like the signal to noise ratio, and you need to kind of measure that and be cognitive of, it's something that can really blow up. Um, but that's like, in optimization, for example, you can add robustness there. So that like a field that calls like robust optimization. And that ad says, okay, you have like a point estimate of, let's say, 1.2%. Actually, it's not that. It's actually an interval around that point estimate. So you're optimizing against that interval rather than 1 point estimate. So there are like other ways that you can build robustness. Like that's one in the backtest because that's one we discussed. But then you also have on the model validation and model creation. You also have on the portfolio construction. So like various checkpoints that you have the signal generation, but you can fail at the model. That's why it's kind of important to have these different kind of checkpoints.
No, that's interesting. Um, so
In terms of
yeah, yeah. In terms of position sizing, that's another topic that I would like to touch. Since we're on a very fast-paced conversation. Um, about position sizing, what do you think about like Kelly criterion, fractional Kelly, adjustments for the Kelly equation itself? I can speak from my end that that really like for me that really related to the risk engine of the trading strategy or the system that I'm actually developing because like I really like to make that certain adjustment to for Kelly criterion that I use. But I would like to hear your approach and your proposition about like the topic of position sizing because it is a gigantic topic.
Yeah, but we have like a different approach. So the strategies I'm building are basically cross-sectional strategies, right? And I use an optimizer. So basically, the sizing comes out of the optimizer already ready for you. I mean, Kelly criterion is more, I would say, more for like if you're doing like trending strategies or more kind of individual type of approaches.
What type of optimizer do you refer to? Like, what is the optimizer?
Yeah, well, you need to go back a step again and try to understand, okay, how we're going to build strategies. So strategies that work are startup strategies, and they work cross-sectionally. So you have a cross-section of stocks. Let's say at each point of time, you have the top 1,000 stocks in the US. And let's say again, we have like the momentum signal, and then you like to kind of optimize it. What the optimization does is basically it will give you the weights that will optimize the portfolio value of momentum. So that instead of doing it through heuristically, through a rule, maybe like the Kelly criterion, you can actually plug it into the optimizer. So now you're trying to maximize the weighted average of that signal that you have. And then you can control the covariance, the risk, the turnover, the market impact. And then you also have constraints in terms of how much the maximum position size, sectors, liquidity, all these kind of constraints that go into the optimizer. So usually like big institutions would run through this setup. So that's also part of the framework that we're discussing. So I don't use Kelly criterion. I've never used it. It all comes out of the optimizer because there you control pretty much everything: exposures, risk, turnover, market impact, and then you just trade it.
Hmm. You
Not sure
know,
the answer you wanted to hear, but that's
no,
kind
no,
of
no.
like
Is the exact answer I wanted to hear.
okay.
I don't think that I really direct myself in like
Mm,
extracting the rightest answer because I'm just trying to feature the guest.
yeah, yeah, yeah.
And I think that question that the answer fits even more than Kelly criterion. And let's dive deep into the optimizer. How do you build that
Mm-hmm,
optimizer? What are the main factors for building that optimizers? Now, obviously, you work with cross-sectional equities, but what if I don't work with cross-sectional equities? Or what if I narrow my focus onto four or five or six or even 10 different instruments, which is nothing in comparison to like your perspective and your work. Um, how do you still build the optimizer in order to receive the position size or position sizing, sorry, for your trade entries?
I mean, you can still use it. You can still use the optimizer even if you have like 10 assets. Some factors you need to consider is like what you're trying to kind of optimize there. Um, Again, as long as you have like a strong signal, the sizing, whether you're doing the Kelly criterion or with an optimizer, shouldn't be that of an issue. Like if you have like a really strong signal and you have 10 assets, you can really like weight them inversely, analogously to the signal. So stronger signal, higher allocation to the signal to the asset that you want to trade. Or you can do kind of another approach, which is I don't want to have any more exposure to any of those kind of 10 assets. So you can have like a risk parity approach. So that also will tell you the sizing as well. So they're like kind of different ways of doing it. It kind of depends what you like to achieve. Again, in the optimizer, you can handle a lot of stuff simultaneously. So that's why it's good about it. Now, you need to be careful because the optimizers also are very kind of data prone. So if you change a few stuff and you run the bugs again, you might get like very different results. So then the question is again, coming back to robustness, how do you build like a robust portfolio optimization engine? And we touched a little bit upon, okay, maybe you're optimizing a robust interval instead of point interval, point estimations. And you try to constrain it as much as possible so you don't let it loose. These are some of the things that help you have a robust kind of portfolio at the end of the day.
I got it. Oh, well, that sounds very interesting. Um, okay, so changing the parameters in the optimizer, as you said, will provide you with slightly different results.
Mm-hmm.
But still, market is a very chaotic environment, and you would have to change in a matter of time the parameters. Now,
True.
how do you do it without hurting your positions in the market? and obviously you already have more money inside of the market, so how do you don't hurt it as well, and how do you stay consistent and very dynamic through regime shifts?
Well, that's where the research comes into play. Like once you put everything into production, you still have a research pipeline that still runs the same kind of portfolio production. And that's kind of optimizing all of those kind of parameters that you have. So whatever parameter you have, you don't stick it there and set and forget. You're constantly learning and reoptimizing. Now, how long it depends on how frequently, depends on what frequency you're trading, right? Obviously, if you're trading in 2 weeks, you're not going to reoptimize every hour. And vice versa, if you're trading every hour, you're not going to reoptimize like every week. You need these two to kind of align. So you find a frequency that makes sense for you to kind of update the parameters. And then once those make sense, then you put it over to production and they picks the new kind of parameters. So everything is kind of seamlessly, right? Like you first build all the infrastructure and then you start trading. It's not like, oh, I need to change the parameters, so now I'm going to think about it. You need to be upfront and think of all of these kind of corner cases. So you have the infrastructure ready to be able to maintain them. So even if you want to change the signal completely, you just put like the new signal and then it should kind of find the way into the production. And then it's more of a question. Let's say you do that and let's say now you have a completely new allocation. That's now an execution cost. How do you actually trade and turn over the portfolio? And that happens, in chunks. So let's say your alpha changes completely because of the regime shift. It will take like a couple of trading sessions to go from one portfolio to the other portfolio. Because
Mhm.
of course you have matter
You're
impact, so you need to
actually
kind of
you're actually having a portfolio for different market regimes? Is that what you're trying to describe here?
no, no. But what I'm saying is like you have one portfolio in production, but you also have different portfolios running in research, right? That you're kind of evaluating
So you
and
ignore the portfolio research if the
yes,
regime has been changed.
that's one way to go about it. I don't have like different portfolios for different regimes, but what I'm saying is like you have different ideas that you're running and different ideas that you also control, let's say live in addition to the portfolio.
Okay,
And then that's how you also come up with other insights. Oh, that portfolio is down. Why is that? And then you go and look at it and get more insights from that.
I understand. And okay, and how do you structure the research? Like you're already in production, you have money in position.
Mm-hmm.
Um, you have another research aspect, obviously, that you're supposed to control over. And my question is pretty simple, is what do you actually research? Like what are the parameters that you're looking at? How do you actually understanding the entire point? And how it's still being able to move very, very sharply in between regimes.
Yeah, I mean, first you have the research environment and then you have the execution, right?
Mhm.
So you
No,
don't go,
of course, but you still have execution in production, and you still have the research, which is, you know, in the ready, set, go phase before, like, uh, turning the research, the portfolio that you have in research onto production. That's
that's
what
why
I'm
you
saying.
go, yeah, that's why you go into staging first. So let's say you have, you would like to roll out some changes from research to production. You first roll them out to staging, all the testing, the nomenclature kind of varies here. First, you test them just to make sure that everything works and nothing breaks down operationally. And then one that's good, then you turn it over to production. But these are like all things that run in parallel, right? So you have the research track that runs in parallel. You have the test or staging, and the production, right? Usually, the production you rarely touch it. You'll let it there do its own thing, and then you're basically changing more the research and a little bit in the staging environment. So whenever you have something that you need to roll out to production, you first roll it out to staging, you test it there, and if that's successful, then it rolls out automatically to the prod.
Mhm. That's interesting.
Yeah.
Okay. And then and what are and like how do you detect regime shifts? Like what is your what are the factors that you consume in order to identify those regime shifts in your research?
That you need to look at kind of distributional shifts. So if suddenly your signal has some, yeah, because I mean, once you're doing the backtest, you kind of know, and even for realized performance, you have like a distribution of returns or a distribution of your signal, right? So you know with high certainty what your signal should be doing. And then it's a matter of fact of kind of controlling that and monitoring that. So whenever you see a shift, like a big shift into your model performance, that implies there is some sort of shift somewhere. It could be because some data pipeline broke down. It could be because of the actual underlying investment, it actually in the new regime. Um, but that's like the first kind of monitoring of the signal itself and then of the portfolio as well. Because if you see the individual signal shifting, that will impact also the portfolio to some extent. I don't have like any particular kind of like regime shifting or detection mechanisms. I mean, there are a lot you can do.
You don't
Kind
believe
of,
it?
excuse me?
You don't believe it?
No, but I think it's like very difficult to kind of predict regime
Like
shifts.
you don't believe in those methods.
I don't
That's
believe
what
in predicting regimes. You can identify them a little bit after the fact, but like predicting regime shifts, it's like very, very difficult. And you can see the practice, if it was successful, people would be making tons of money. So that kind of hints you that's why it's difficult. What is important is like once the shift has been identified, how quickly you can rebalance your portfolio so you can adapt to the new regime, essentially.
yeah, yeah. I have a good friend here in Israel. He's
Mm-hmm.
managing, you know, I think couple hundreds. And he told me that if we had someone who can spread out secret about market regime shifts, that would be the complete holy grail for everybody. So,
Yep. Yep. Yep.
still for me, I really like non-parametric, methodologies in order to extract the most out of the market understanding. And still, I would like
Mm-hmm.
to ask you, what do you think about like the methods that are offering that are being offered,
Okay, I kind of lost you a little bit there.
So I was saying that
Mm-hmm.
I would like to understand what do you think about academic research and academic literature and non-parametric tests to evaluate regime shifts.
I don't think it's a problem of the methodology itself. I think it's inherently a very difficult problem to solve because of the how many times it happens, what are the leading causes. So I mean the methods are fine, but it's like you need to be conscious of what you're trying to solve. So basically you're saying, okay, we have a performance A, and then it will go to point B. What is causing that shift? That's basically what regime shift is all about, right? But historically, all of those indicators that made you shift from point A to point B, they're not the same. So it's very difficult for the model to kind of capture all of that. Now, lately, there's a lot of about causal inference and causal theory, which again, that's basically what it's trying to identify, like which are the causal effects of driving that. But at the same time, I think it's also very, very difficult. It's a framework that describes what you should do, but I haven't seen like any, at least in the research space, any good application of giving you the actual answer. Oh yeah, momentum crashed because of that. Um, and I think that's why it's inherently very, very difficult problem. And instead, you kind of focus on being able to identify it quickly, and then you can kind of capture it.
Mhm.
So the methodology is pretty fine. Like all the methods are pretty fine. I mean, there's
Yeah,
nothing wrong.
like, basically. Yeah, I think it is another tool to extract some information out of it. Um, Okay, University of Macedonia, Director of Philosophy, PhD candidate, Machine and Deep Learning. Berlin, congratulations, by the way.
Thank you.
And Machine and Deep Learning for financial time series. What do you think about it? Let me understand. What do you say? What do you think about deep learning? I reinforcement learning also. That could be another interesting topic. And
Hmm.
yeah, let's dive deep into it. By the way, University of Macedonia.
Yeah, yeah, well, that's in Greece though. That's in Thessaloniki,
That's in Greece.
Greece. Yes, yes,
That's in-
yes, yes.
Okay, brilliant.
Yeah. Yeah, I mean, as far as deep learning is concerned, is kind of used pretty heavily. In the shortened time frequency is been quite successful. So again, market making and
Deep learning.
yeah, yep, yep.
Okay,
And
how
kind
do
of
you
like
see it?
say it again.
How do you see deep learning nowadays?
Well, I think it kind of maintain its edge there. Again, I'm not a market maker, but I'm pretty sure they're kind of using it quite extensively in these kind of shops. Um,
Why market makers use deep learning?
because they have a lot of data to train the models. I mean, not only market makers, but basically, essentially, anything that's kind of I would say 1 hour, you can reliably use it because you have a lot of data to train the models on. Anything beyond that starts to become difficult to train the models. Like deep learning models are very parameter heavy. So you need to have a lot of data to train them. And just to give you an example, LLMs has been so successful because basically the corpus of text is pretty, pretty huge.
Absolutely. Yeah.
So, you can try and successfully train them. In finance, especially in equities, if you have like, even if you have like intraday data, it's not that of a lot of data. I mean, if you go to daily data, you have like uh, one instance per day, 20 trading days. So basically, you have like 20 times 12 for a year, which that's not enough. But even if you take that by 10, it's still like very, very little. So that's why like the shorter time frame increases the bandwidth of the data you have to train them. So now you have a lot of data for one particular instrument times the different instruments. So now it becomes a little more meaningful to train them. Um, but I think now the edge is kind of
What is the output? An output is the execution itself.
output is basically training the signals and also, yeah, more on the execution side. And basically be able to capture all of this kind of very quickly. So that's why they rely on like GPUs and all this kind of infrastructure. So it's kind of more of an infrastructure play to be able to train all of these models fast enough to be able to also execute them very fast as well.
Mhm. Okay. Okay. There's a very large firm we all know that was I really like their YouTube videos where they describe like, their advances and what do they do. And to be frank with you, they have interviewed one of their head of desks, and he told,
Mm-hmm.
yeah, we have found a very reliable methodology to use deep learning extensively and extend to accelerate our trading capabilities, which is, it's interesting because many of those quantitative research, quantitative engineers, PhDs, professors, with gigantic advancements, they don't really like the unavailability, like they're unable to articulate what the model have done or decided to do
True.
because this is a very weight heavy. Um,
Yeah, a lot of people don't like machine learning because of that, right? And if you go to traditional shops,
not
they
even
don't
not,
use
even-
it
not, even- not even
because
machine
of
learning. I'm speaking about deep learning. Machine learning is another topic in my mind that
yeah,
is
true, true, true. I mean, yeah, I mean, yeah, true, true. Deep learning is even harder to explain, I guess. For machine learning, you have some kind of, I mean, they're kind of all under the umbrella of machine learning. Just deep learning is like a very specific type of the neural networks that is part of the machine learning, right? But yeah, like
obviously
people
also
really,
also reinforcement.
yeah, yeah. Reinforcement learning is also that. I'm not an expert in that one, but I know that they've used that for trading. I know instances where they use that for successful kind of trading. But yeah, I mean, some people really want to understand everything from A to Z. That's perfectly fine. There are other shops that say, well, we trust the process, we trust the statistics, and then we'll test it, and if it makes sense, we'll put it in production. I think you just have to know what philosophy you would like to go about. Like at the end of the day, it's like everything has to be like what philosophy you have and what you're after, and then pick the right tool to kind of do it.
Hmm. I understand. Okay. And machine learning. What do you think about machine learning? How do you like, take into advantage machine learning capabilities into your models?
Yeah, I mean, machine learning now is like all text LLMs. I mean, the way that the coding changes, it also affects quant research as well. I mean, I've been testing, Claude and Claude AI, Claude Code, and it's really fascinating at how it can speed up the whole research pipeline. So it can literally like try to create features along with humans. And I know hedge funds already that have been doing that. So that will become a lot more of a theme going forward, I believe. So you're having all these kind of agents that they're built signals and they are kind of running in parallel with humans. So that's why, going back, if you have that kind of evaluation pipeline, you just feed it with signal. It doesn't matter like who created that signal. If it makes sense and if it kind of passes all through your checkpoints, it's like a valid signal. So I think machine learning is going probably towards that direction, using the agents, the LLM agents to build features. Um, because you can also like utilize all of these tools. Like you can go to Claude and tell him, hey, I would like to build a signal that uses, like a deep learning model, a light GBM, and take an assemble of that and cluster on top of it. So, you can get like really fancy and he can do it like, I don't know, in like 10 minutes. So the iteration process and the iteration lifecycle changes a lot. So I think that's where things are kind of headed, to be honest. And it's kind of like very interesting.
Mhm. Um, Gradient boosting or other types of machine learning? What is your preferred methodology?
And light GBM is kind of battle tested. I think XGBoost is kind of the same, but light GBM because they have this kind of horizontal, the leaf-based approach. I think they're a lot better, more faster. But usually, like a tree-based approach is like your first go-to. You go regression, tree-based approach, and then if you need something more technical, in my opinion, you go to kind of neural networks. But that's like kind of a sequence of models I would try out.
Mhm. Brilliant. Okay. Um, Last question for today. I think that I have left with nobody.
Okay.
Uh,
Yeah, I think we
uh,
covered it quite a
we,
lot, right?
yeah, we have covered so much that hopefully sometime we'll have a chance to dive deep into like
Specifics.
a
Right?
specifics of every aspect. But
Mm-hmm.
last question, out of your perspective, obviously
Mm-hmm.
the market's getting much more efficient each and every single day, and liquidity comes into the market, and still all the financial assets by any mean and by any scale are getting much more efficient. I would like to ask you, how do you envision the quantitative research in the next year and a half? You have mentioned clock acceleration. You have mentioned your proposition about like how do you do your research. Everything like goes very fast, and towards 2026, all the researchers says that AGI will not come, but the CEOs will. Everything is not very understandable, and I really want to hear your assumption.
Yeah, that's a good question. I mean, first of all, I wouldn't say that markets are like fully efficient. I would say there are kind of inefficiencies that you can exploit, and that's why they're
Yeah,
like
of course,
people need.
but it is impossible from
Yeah, yeah, but I understand where you're coming from. Yeah, yeah. I mean, they are efficient as
2010 to
yeah,
to to explore inefficiencies in the S&P 500, for example.
true, true. Yeah, yeah. But in order to kind of capture those kind of inefficiencies, you need to look always at the data side, right? So the question for me is like, okay, how can I, like, what data sources can I use to capture more of what I'm trying to explain? Because at the end of the day, you would like to explain returns, equity returns, right? So what is driving returns? That's kind of always the pinnacle of the question. So aside of the infrastructure of all the methodologies, you always need to ask, okay, what can I do that that the other market participants are not doing? How can I think a little bit different? What is my edge, essentially? So because of the market efficiency, as you mentioned, you need to find where is your edge. Could it be trading very, very frequently? We also see that now SFT funds are actually going to the mid frequency and try to diversify. We see long-term players also kind of diverging a little bit to the mid frequency. So I think you need to find like a sweet spot where you're not getting caught by all these headwinds about macro funds, and need to be able to kind of balance all of these risks. So to answer your question, I think the research will be a lot more unified in terms of using a lot of different data points, from a lot of different kind of input sources. For example, like crypto is another asset class now that's becoming a lot more institutionalized. So I would definitely see treating that as another input to your kind of equity construction. Like as you have oils, interest rates, I'm pretty sure people who are looking on kind of on-chain, off-chain crypto liquidity and try to figure out, how that connects to S&P 500 and, US equities. Um, so that's what I would say is kind of like, um, probably my assumption of the next kind of year or so, especially after 2025 that we saw a lot of macro headwinds. People would definitely pay a lot more attention into that and building, their exposures to all of these different asset classes.
Mhm. Brilliant. You know, um, I manage, tons of different conversations a day
Okay.
with plenty of people. And like the conversation that me and you just had was extremely paced, which is interesting because we have dived deep to so many, like to a variety. Like I think that we have dived deep into
Yeah.
like, everything that we can probably think of. And this is special. Like that capability of you to be extremely sharp, extremely quick, like inference time equals zero. And
Thank you. Yeah, yeah.
and yeah, going very, very fast and exploring it's a thing that like much appreciated with
Yeah, thank you for asking the right questions, I guess.
my end and I really like that attitude. And yeah, so Harris, first of all, I would like to say thank you in Greek, which I would desperately, which I would love to
Go
know
for
how
it.
to say. Uh, how?
Ευχαριστώ.
I will say thank you in English.
Okay, and leave it to that.
I will continue with my English. And again, I want to thank you very, very much for your discussion about everything that we have discussed about. I had a I had a pleasure to speak to you, and it was very, very fascinating. Very
Yeah,
fascinating
likewise. Thanks
experience.
a lot for having
Okay,
me. I think we had like a
my
really
pleasure.
interesting and insightful discussion.
Brilliant. So, guys, until next time, uh, and hopefully that we'll have another chance to interview Harris. Um, Next time, we promise that we're going to dive deep into the specifics of each of two subjects, but we're going to dive deep into the subjects themselves. Okay, so thank you again, Harris. Thank you. I'm very, very grateful. And
Thank you.
yeah,
Thanks a
guys,
lot.
thank you, and see you in the next time. Bye bye.